Docker, so I will let Gaji go ahead and start.
Thank you. Thank you. Good evening. This is my second time attending the HPCC Systems Platform conference, and my first time as a speaker. So I'm pretty much excited to be here with you. So today we would like to show a little bit of what we've been working on for you. As engineers and members of a research and development team, we have the opportunity to play with some of amazing cutting-edge technologies. And some of those enable us to improve our development and deployment workflow. And some other ones improve the user, the way that users interact with our platform. Following that same culture of making things easier, faster, and more secure, while providing you, the users, more functionalities, we would like to present to you today our latest solutions, which is Docker and Kubernetes solutions for the HPCC Systems Platform. The HPCC Docker and HPCC Kube. So what is Docker? Docker provides us a way to run applications securely isolated in containers packaged with all of its dependencies and libraries. What is Kubernetes? Well, Kubernetes is an open source container system for automated application deployment, scaling, and management. Some of the main features of Kubernetes are container grouping using pods, self-healing, auto-scalability, DNS management, load balancing, and rolling update or rollback. And of course, resource monitoring and logging. So why do we want to talk about Docker and Kubernetes today? The answer is simple. After a lot of research, we found that Docker and Kubernetes are the most prominent and best suited for what we want to do with the HPCC Systems Platform and the cloud. So at the end of this presentation, you should be familiar with our current HPCC Systems Docker and Kubernetes deployment workflow, able to use the HPCC Systems Docker Kubernetes in your development workflow, and being able to contribute to the HPCC, to the integration of these two technologies with the HPCC Systems Platform. So let's talk about the HPCC Docker project. To make things easier for you, we provide you our latest HPCC Systems Platform Gold images through two different libraries, Docker Hub and Amazon Elastic Container Registry. So for Docker Hub, you just go to hub.docker.com/u/HPCC Systems. And of course, we host our source code on GitHub. And to get to that, you just follow this link. So what's in the box? What does the structure of the project look like? What are the directories, the files? Let's take a look in here. At the upper level, you'll notice that we have CE, which is the community version, and also LN at the bottom, which is for internal users. At the root of that directory, we have one of our Docker files, and then we have a base with another directory which has another Docker file, and of course, our internal version, like I said. So let's take a look into one of our Docker files, which is the one at the root level of the CE directory. If you look at the bottom over here, you'll notice a snippet where we download the package. Basically, that file is responsible to install the HPCC Systems Platform. So now you know where to get our Docker images. But how do you like pull them to your local machine? And to do that, you just do a Docker pull, like this. So if you look at the upper level, you see where we do the command, and we actually get the latest version of the platform using the latest tag. Now you have the image. How do you want it? To want it, you just do a Docker one, like this. Let's take a look. So here you have where we run the latest tag we pulled earlier, which just happened to be the community 7422 gold. If we do an ECL -- version, we get that. And in here, you will be able to step in, you'll be right into the container. But the platform itself is not running, so you have to run it yourself. And to do that, you just do it as usual, like this. And right now, you have HPCC running into a Docker container. So now you know how to get the image, how to run it. But what if you want to build it yourself? And to do that, you just do this. You step into the directory, into the CE directory, and you do a sudo docker build. Let's take a look. Here we're building like a different version, which is 7424 RC1. We normally provide you the gold releases, but we don't provide you RC releases for Docker. So if you want to build an RC, you can just do it like this. So right now, if you look at the end, you'll see a dot. This dot means that, hey, my Docker file is at this current, at the root level of this current directory where I am, which is the CE directory. So now you have your HPCC system running, and you like to test it. Just like a unit simple test to make sure that everything is okay. And we provide that to you as well. To do that, you just do this command. And if we take a look into the file itself, the test file, you see at the upper level, we start the platform, and then we have our basic ECL code to test it. We run the ECL test, and we pass the result. And that tells us whether the test has been a success or failure. So now you know how to build the HPCC system yourself. But that package, the HPCC system package, is being pulled from our website. As developers, you might be working on a feature that you want to test, right? And that is not going to be on our website. So how do you want it? How do you test that feature with Docker? And that's where the project comes in, because it enables you to test your feature very quickly, very easy. And to do that, we introduced our Docker multi-stage build. And if you would like to learn more about that, you just go with the documentation for Docker multi-stage, and you will get all the information that you want. So the usage is pretty basic. We just build the HPCC system platform, and then we create the Docker image all at once for you with a single command. So let's try to build our community edition using Ubuntu 18.04. So if we look into the structure for that, you'll notice like 3 Docker files and then other directories. At the base here, we have a Docker with our prerequisites for final Docker images. And then build server directory, we have our HPCC systems build server image Docker file. And then at the bottom, we have our 2 stages Docker build Docker file. So to build your private branch with that feature you've been working on that you want to test before you do pull requests, you just do this. So let's take a look. Let's see that in action. Here I'm building a private branch, which I'm testing for a user. And if you notice, I step into the CE directory. And here I pass my credential, and that is optional. It's not required. And you only have to pass that if your GitHub repository is private. So you have to pass your username and password. And it is as simple as that. And of course, at the end, we locate the Docker file for the build. So far, you know how to get our image, how to run it, how to build it yourself, how to test your features. But what if you have to deal with hundreds of containers? How will you manage them? How do you start them? How do you group them? And for that, ladies and gentlemen, Xiaoming.
Thank you. Okay. Build with the private. Oh, how I go? Oh, sorry. The first time use it. Okay, so I'll talk about HPCC Kubernetes. That's actually the project we put in GitHub for how we deploy the HPCC. It's a lot of samples and a lot of information. So I will talk about the deploy the HPCC cluster for Kubernetes on the Amazon, because that is where we have account. Our company have a good cooperation with the AWS. So what I was using is called Amazon Elastic Kubernetes Service. Now, traditionally, people probably need to provision the Kubernetes themselves on the AWS. And now the AWS provide this EKS that's easy to create the Kubernetes environment on AWS. So it's easy to provision and easy to scale. And also they support multiple available zone. And also you can integrate with other AWS services. So the provision method actually you can do from the console, or you can do from command line. The command line provide the link. You can download the code. And for this demo, I will all the demo information is in the HPCC Kuber repository. And I will demo is use the code stateful set with the EBS. That's the volume you attach to the SOAR and the RAG-Sys. So I will deploy basically one DARI, one support node, and one ESP, and then 2 RAG-Sys. The second, first RAG-Sys is 2 node. The second RAG-Sys, actually the mistake actually should be 1. And then there's SOAR, 2 SOAR slave, and SOAR master. We do have a convention for how you name the pod. That's how we distinguish when you deploy to see what function for each pod. So the first one is the HPC system component, and then your your cluster name. That how we generate the environment smell. We do add another node called the HPC admin. That node basically will collect information and then generate the environment smell. And we use the command line EKS control tool to generate the Kubernetes environment. So here is the script. You actually run the EKS control to create a cluster. So that's the basic command. And then you have a bunch of parameters how you want to configure your Kubernetes environment. For example, you pick up 2 zones. That's required if you have 2 or more than 2 nodes. And then how many nodes you want. Basically, how big is your cluster. So you run that script, you will see at the bottom, when it's ready, you show that the cluster you created is ready. Before you deploy the HPC cluster, we actually need to do some bootstrap. Basically, one thing is we need to grant the Kubernetes API access. Because in the admin node, we use the Kubernetes API to communicate with each pod. At the right side is the information you generate the environment smell. Now here is how we define which API you want to access. And we said we give a namespace to default. That means every pod we defined will be in the default namespace. We didn't create a new namespace. OK, you run that bootstrap script. That's how you run it. And then you can deploy your HPCC cluster. Now, in the Kubernetes, you always run the kube control command line to create, to apply with the pod definition file to create a resource or the pod and the service, etc. So we said we have about 9 pods deployed it. That's how you run them. And here is the tools example for the pod. The first one, the left side is ESP. There's the service name, and there's the service port we want to expose. Currently, this example, we only expose the ECL watch, that's the 8010. And then the service type, that we use the load balance. And then is the controller, that basically means this pod can be scaled up. And that's your pod name with keep convention is the HPC component and then the cluster name. And then this is the Docker image. If you give this, we didn't tell which URL, they will put from a Docker hub. And here is the port we exposed. Actually, if you want to use all of them, use the port to be listed in your service. But now we only list the ECL watch. For the Roxy part, we have a headlet service, and we have a volume definitions. And this type is called stateful. The stateful is useful. They can dynamically create the EBS. Otherwise, it's not possible. So when you deploy your pod, you can query the status. You can see we have 8 pods. All of them is ready and running. That's the deployment type. And this is the stateful set type. And for each Docker, you have they call entry point. Now, for old HPC, the component, we didn't run anything. We run actually is SSHD. That's basically the entry point. But for the admin node, we do run the one script called event watcher. It basically will monitor the Kubernetes API for all the pod statuses. When the pod is available, they will use the information to generate the environment smell. We also provided tools to start, stop, and get status of the cluster. Now here is the cluster we deployed. Now when the HPC cluster is deployed, you can go to the ECL watch to do whatever you want. So to get the the ECL watch API, the IP, you run the Kubernetes service. You get either the external IP or you get the fully qualified name. Here is the ECL watch. And if you go to the EC2 on AWS, you will see we have a 3 node because they said at the beginning, when we provisioned our cluster, the Kubernetes, we say that the node will be either one, a minimum 1, maximum 4, but by default is 3. And since we start Roxy or SOAR, we start bunch about the volumes. Now, for the scalable port, you can use the Kubernetes command to scale down and scale up. Now, we want to, this one, we try to scale up Roxy, the cluster 1 from 2 nodes to 4 nodes. That is how you run it. So you see when you start it, you see the 3rd node is coming. Now this deployment, we do this sequentially, so they actually one by one. First one finish, and then the second one will start. And here is the extra 2 Roxy node added. And this show in the EC2 volume, you will see 2 nodes is added. And same thing, you can decrease the node when you don't need them. And at the end, you can stop the cluster to run the, we provide a script called stop. Or you also can run the Kubernetes control, delete each pod file to stop the cluster. Remember, when you stop the Kubernetes cluster, the volume probably you stay for the EBS case. So you need manually to run the Kubernetes delete, PVC, and then the pod name to delete the volumes. We show deployed with the EBS, but actually you can do with the network file system. We call the Elastic File System, EFS, and we have 2 samples in our repo. And also you can use Helm charts to deploy these 2 things. And we only do the EBS. Let's compare the EBS with the EFS. The EBS is performance better and cheaper, but it's hard to reuse because when you cross the available zone, it's really a bit hard because when you have a pod, you must have a volume in the same zone. You have a different zone, then it will be hard to reuse them. And also the multiple volume zone probably doesn't benefit for the HPC case because we can guarantee the data, can be identical on both zones. For EFS, it is easy to use. You don't need stateful set, but its performance is not good as the EBS, and also it costs a little bit more. The EKS, the cost mainly is from the EC2 instance. So if you want to control the cost, there are 3 methods you can do. You can either delete or restart your cluster, or you can use the EKS control to scale how many nodes you need. Or Amazon provides a spot instance that is cheaper than the normal nodes. Okay, so you deploy on the cloud is good. But sometimes you want to work locally with your Kubernetes. So we show here is use the local Docker Kubernetes to develop and testing HPC platform features. So to set up the local Kubernetes, there is a recommended way, they call it Mini Cooper, that is provided by the Kubernetes that's put on Windows and Linux and the Mac. The other popular method is you install your Docker, Go, and the Kubernetes source code, and then compile it. And you can do on Linux. That is the one we will use. And then on Mac, and in the future, when the Windows Subsystem 2 is available, you probably can do that. And yeah, here is our repository information for the local deployment. So what is the issue? The issue is an open source project which try to resolve a common problem when people migrate their product to cloud. This problem includes network control, security, monitoring, and logging. So why use ISTIO? The ISTIO makes it easy to create a network of deployed services with a load balance, service-to-service authentication, monitoring, and more with a few and no code change in your code. And ISTIO support various Kubernetes platforms. So in our example, we will show a small HPC cluster, and we will demo some Kubernetes, the ISTIO's functions. Basically we will do is ESP, ECL watch, network, and authentication. The key component of ISTIO on the Kubernetes is to inject intelligent edge proxy called Envoys into your service. This proxy will mediate and control all the network communication between the service and others. So what in here we say we only concerned the ESP part. So the ESP part will contain two containers. We will see that. And the issue for Kubernetes, you can download this URL. So when you download the issue for Kubernetes, you want to run the script to basically install the issues for the issues to the Kubernetes. The Kubernetes, the plugin or maybe extension is through the code the customer what do you call it? Services definition. So this way you can extend all the function of for the Kubernetes. And then you will set up settings. We will set up settings for this demo. And one of the settings is the add the port 8010. Because by default, the issue only handled a well-known port. So we need to add this port 8010 to their integrated gateway. And also we will map this port to the host port because we deploy on the local. And the right side is what the result when you run this script, they show all the service available. And before we start the deploy, we want to turn on several things. One is we want to turn on basically for the mutual TLS. Basically, it will deny everything. So you need to add the settings to allow either traffic or the authentication user access. So that's the setting to by default deny everything. And the second file is we say we will allow the HPC 22 port, that is SSH, to open for the ESP port because we use Ansible to control the cluster. That's why we need this support. The third one is who can access this port on the ESP node. We say it's for the namespace default. That's everybody deployed on this namespace can access this port. So again, we run the kube control to apply these three files and to enable the setting. We also need to do the similar bootstrap to enable the API, the Kubernetes API, and also the settings for the environment XML. Now we will deploy the HPC cluster. Now we have 4 HPC nodes, but remember, look at the third one, that is the ESP. So the ESP is special than all other because we not code the Kubernetes command, but we code through the issues because they will inject another container. See, when you deploy, you will see in the ESP there are 2 containers. One is our ESP, the other one is the Envoy. And after deploy, we make sure the ESP is running, and then we can go to we get the port. That's actually we did the define. We actually manually defined, but you can query this one also. That is what is the local port mapped to the 8010. Now you can go to your browser to try to access the ECL watch. But you will get this. You will get it cannot be reached. The reason is we said that we denied by everything. You need to, to turn on anything you want. So what do we need to do? We need to add the request on the port 8010 to our gateway to process this request. So here is the file, and that's the bottom is what do we mean? That we say we allow the ESP service to handle the port 8010 request. So after you apply this gateway part file, the YAML file, and you try again, now you get a different error message. They said access denied. So why is access denied? Because even though you allow a ESP to handle it, but didn't tell who allowed to access. So what you need to do is say you need to tell the system who you allow to access the 8010. Sorry. So there are two files. You define your policy. Basically, you say the ESP will be the system, the vendor can access ESP, and then the second file will say who can access. We currently set is anybody, but you can set the particular IP, particularly the host name, or even some you define service group can access it. So you apply these two files through again the same the Kuber control apply these two YAM file, and then you try again. So now this time you get access correctly because we do say, oh, we allow anybody through the browser to access the ESP, and that's what they did. And the other interesting with the issue is that because issue is a lot of functions that support the issue. We only showed very, very little. You can do is authentication. There are 3 level things you can do the authentication, and then they do support the telemetric and also the metrics and the logs things. And also I need to mention is the issue is open source, but the AWS have their own things. It's similar to the issue. They call it AWS App Mesh. That is available on the AWS. That is we demonstrated today. So we did show people how to use Docker, how to build Docker image, how to build a development Docker image, how to configure the cluster. We didn't show directly this, but actually when we deploy the admin part, we used this code to control and generate the image smell and start and stop the cluster. And then we also show the Kubernetes deployed on the AWS with EKS, and also we show the demo on local Kubernetes environment for the issue. That's it for our presentation. And any questions?
No. So if there's no questions, we're going to take a break right now. So if everybody can reconvene at 3:15 in the grand ballroom. Thank you, guys.
Thank you. Thank you. Wear the other blanket. Some made me so. I didn't realize we didn't read this thing. We read it. Sure.
When you scale up or down,
For the Roxy control. But actually you can do the ESP. The Roxy is really not make sense now because actually when you scale up, scale down, you reconfigure the environment smell currently. So, but ideally now it's working is you can do the ESP, ECLCC, this kind of thing. It's not data related, so you can scale up, scale down. Actually, in the sample, I didn't show here because we don't have time. You can auto scale it. That's very easy to just write they call the auto scale part, the YAM file, and then you can create a matrix. Say, oh, I want a CPU higher than 90,